Good morning, precalculus class. This is Mrs. Blodgett with a lesson on conic sections and specifically the parabola. Take a look at this warm-up, pause it here and try it on your own, and then you can see the answer. Okay, here's your answer. First thing you should notice is that you know this is a circle because a, which is the coefficient of the x squared term, and c, which is the coefficient of the y squared term, are both the same value. They are both -2. And if they're the same, then you know it's a circle as long as they both exist. So the easiest thing to do when that is the case is to divide out both sides of the equation by that coefficient, which is -2. And when you do that, you end up with x squared plus y squared minus 4x plus 6y plus 1. And 0 divided by -2 is still 0. Then I'm going to group my variables. So you got your x variables and your y variables, and I move the 1 to the other side. And we complete the square twice. So -4 divided by 2 squared is 4. 6 divided by 2 is 3. 3 squared is 9. If you add them here, you add them here. And then we complete the square. So we get x minus 2 squared plus y plus 3 squared equals 12. When it's in this format, we know the parameters of that circle. We know the center is at +2, -3, and the radius of the circle is the square root of 12. Don't forget, that is r squared, so you've got to take the square root. And we know 12 is 4 times 3, which is 2 root 3, and I use my calculator. It's approximately 3.5. So I can quickly draw a graph by plotting 2 over, 3 down, and then I walked 3.5 in 4 directions and made a little X, and my circle, the best I could draw freehand, is going through those points. All right, now we're going to learn about the parabola. All right, so the first thing you should see is the parabola is this equation here. And you can either have a parabola that's considered horizontal, kind of looks like this, like opening to the right, or maybe it's opening to the left, or a vertical parabola. Vertical parabolas are the ones you studied when you studied quadratics in Algebra 2, and they can open up or open down. We're going to go through these equations in more detail because they don't look like the quadratic equation form you've looked at before. One thing that's important though is the product of the a, coefficient of the x squared term, and the c, coefficient of the y squared term, is 0, which means one of them does not exist. So you can have a horizontal parabola if you only have a y squared term, or you can have a vertical parabola if you only have an x squared term. So that's the important thing to keep in mind when you're looking at the general equation of a conic. You can quickly determine whether it's a circle or a parabola at this point. All right, so this is your definition of a parabola. It's the first time you've probably seen this definition. It's defined as the collection of all points P in the plane that are the same distance from some fixed point F, which we call the focus point, as they are from some fixed line D, which we call the directrix. So just for instance, if I look at this distance, this point on the parabola is this distance from F as it is this distance from a line. And remember, the shortest distance from a line to a point is the perpendicular distance. So as long as these are equal, that's a point on this parabola. This is a point on the parabola. This is a really important point. It's called the vertex, and we can see that this distance is equal to this distance, and we call this distance P in this case, and we'll talk more about that. Here's another point on the parabola, and we can see that this distance is the same as this distance as long as it's drawn well. And it kind of forms a curve. So these distances are all different as long as they're the same between the point to the line and the point to the focus point. All right, let's look a little bit more here. So these are those equations I showed you before. But the standard equation of a parabola with vertex at hk, so we know the coordinates of this vertex, and p is the distance from the vertex to the focus and the directrix. So these two, this variable p and this variable hk, variables hk go into the equation. If it's a horizontally aligned parabola, then you have a y squared term, and know that k always goes with the y and h goes with the x. And if you have a vertical parabola opening up or down, then x is the squared term, and you always put the squared term on the left. Notice that 4p is kind of like the inverse of the a value that you dealt with when you were studying parabolas in Algebra 2. Let me just move this down a little bit more because I want you to see. Here's the form. Get rid of this. Here's the form when it's y equals. So we studied this parabola here in Algebra 2 class. So y equals a x minus h quantity squared plus k. And that was your horizontal transformation shift and your vertical transformation or shift. And this was helping us with the width of that parabola, or how wide the opening was. So that was equal to a. The key is when p is positive, it is opening up. And when p is negative, it is opening down. So let me just write that in here. P is positive, p is negative. Likewise, if it's in the horizontal, you have a y squared term. So x equals, and here p is positive if it's opening to the right, and p is negative if it's opening to the left. So that's your definition and some of the key components. Another thing to know is if you look at the shape of the parabola, this distance here through the focus point to these two symmetric points, this is going to be the distance 4 times p. So that is, it's called the latus rectum, and that is the distance 4p. So if you're trying to sketch an opening of a parabola, you can go p over to find your vertex or your focus, and then go 2p up and 2p down to get how wide the opening is on any graph. Okay, here's our first example. We want to find the equation of a parabola with vertex at 0, 0 and focus at 4, 0, and then graph the equation. I'm actually going to start with the graph because that'll help me with my equation. So I'm just going to draw a little coordinate plane. Here's your vertex. I'm going to label it V. And here's your focus point, 4, 0. So the first thing I know is that my parabolas will always open up from the vertex around the focus point. So this means it is a horizontal parabola, which means it's a y squared, and it's opening to the right, which means p is positive. Okay, and I can actually find the p value. That's the distance from the vertex to the focus. So in this case, p is positive 4. Very important information. The other thing is, I know that the distance from the vertex to the focus is the same as the distance from the vertex to the directrix. So here is my directrix, and that is a vertical line at x equals -4, because it's vertical. And now if I want to sketch my parabola, I can quickly do it because I know that the opening, the distance perpendicular to the axis of the parabola will be 2p. So if p is 4, what I need to do is go up from my focus point 8, all right, up here, and that's going to be 1 point on my parabola, and I'm going to go down 8, and that's a point on my parabola, and I can draw my parabola. So this distance here is 4p, or 16, 4 times 4. All right, let's write our equation now. So the first thing I'm going to do is write the standard form. So we have y minus k quantity squared equals 4p x minus h. And hk is your vertex. So in this case, they're both zeros. So we're going to just make this 0 and this 0. And we know p is 4. That's the distance. So when we are done, we have a very simple y squared equals 16x. And that is the equation of this parabola shown here. When you have the vertex at 0, 0, you're going to have very short little parabolas where there's no parentheses needed or anything like that. In the second example, we have the equation in general form, and we need to find the vertex and focus of this parabola. First of all, I want you to know that it is a parabola because you have an x squared term, but you do not have a y squared term. So immediately, with an x squared term, I want you to think, all right, this parabola is opening up or down. We don't know yet until we go through the work. So we are going to complete the square. I'm going to group my x terms on this side of the equation, and I'm going to move the other two terms, the 4y, move it to the right, and the 8 will move it to the right, to the other side. And we have to complete the square on the quadratic term. So 8 divided by 2 is 4, and that 4 squared is 16, so I'm adding 16 to both sides. And now I go ahead and factor it and end up with this. And here we have 4y plus 8. Now we don't want to leave it like that. Whatever the coefficient of the linear y is, in this case, we want to factor it out because that's going to end up being our 4p value. So I'm going to pull out the 4, and I'm left with a y plus 2. Now we are in the standard or graphing form of a parabola, and we can identify some key information. The vertex is at -4, -2, because it's x minus h and y minus k. 4p equals 4, so p equals 1. And so we also need to find the ordered pair for the focus in this problem. So I'm just going to graph this real quick. -4, -2. And we know this is opening since this is a positive 4, where it's opening to up. So I'm going to walk a p-value here, and it always opens from the vertex around the focus. And so it's opening up here, and my focus is at the point -4 over, but only down -1 because it's a difference of p of 1. If I want to sketch this real quick, I know that my directrix is here, the opposite direction. So my directrix is at y equals -3. Okay. And I'm going to take the focus and walk 2p in each direction. Boy, I really ran out of room on this one. And then I know how this looks when it opens up. There you go. That's example number 2. All right, this last equation gives you the graph of a parabola and asks you to write its equation. So I hope you can all see that the vertex is at 2, -3. But we don't know where the focus is or what the p-value is at this point. You can't assume that it's right here. I mean, you might be able to say, all right, is that double that? And it's not. But we do have a point on the parabola. So we're going to use that xy given to us and what we know with the vertex to find the actual equation. So I'm going to write down what we know. First of all, this is a parabola that's horizontal and it's opening left. So that's important. So I'm going to write down my equation of a parabola that's horizontal. And know that p is going to be negative when we're done. Okay, and I'm going to now plug in my vertex. So y, the k value is -3, so that's a +3 squared equals 4p x minus 2. And we don't know what p is, so I'm going to now take my ordered pair, -1, 2, and plug that in for x and y and see what happens. 2 plus 3 squared equals 4p, -1 minus 2. And so we end up with 25 equals 4p times -3. So it's not very pretty, but we end up with 25 equals -12p, or p equals -25 twelfths. Ick. Well, regardless, that's what p is. So now we can write our equation. Our equation is y plus 3 quantity squared equals 4 times negative 25/12, which we'll simplify in a moment, times x minus 2. And the equation is y plus 3 squared. 4 goes into 12 3 times, negative 25/3 times x minus 2. But the p-value is about negative 2, so you can see now it's a little bit more than negative 2. Right here is where the focus point is. And then you can also find out that right here is your directrix line. All right, but there is your equation. All right, so it doesn't matter how messy it gets, you just need to solve for p and plug it in.